yeah, last but not least, so her project is very exciting, and I think Danica is probably one of the most humorous students we had in our classroom. There's never a dull moment with her, and yeah, I think she really like lit up our classroom and managed to do a lot of work on her project at the same time, which was very impressive. So yeah, here's Danica with her project.
Hi everyone, I'm Danica. I go to Monte Vista High School, and for my project, I chose to do the wrist rehab device because I'm a table tennis athlete, and in table tennis, wrist injuries are probably one of the most common injuries. So I wanted to make something that would help the community out a little bit. So for my base project, I used a flex sensor, which is a resistor, and an accelerometer to measure the angle of your wrist. If it bends too far down, then the piezo buzzer I added will start beeping. So when it's flat right now, it's not beeping, but if I bend it too far down. And for my modifications, I added an LED ring that will half of it will light up red based on which way you turn it. So if I turn it down this way, the red light will light up this way, but if I turn it far back up, then this half the LED will light up. And I also added commands on my phone. For example, if I type in stop monitoring, then the device won't monitor and the piezo buzzer will beep even if I turn my wrist down and up. And my final modification was I coded the accelerometer to monitor how many wrist turns you do and what exactly counts as a wrist turn. So when you type in the commands, it will ask you for how many you want, and let's say I want to do 3. Then you have to calibrate it first, which means that you have to hold it at about 0 degrees for 3 seconds, and then there's a blue loading light that goes around while you calibrate it. I don't know if you can see the light, but I'm trying to like get it to. And then after you can start doing your wrist turns. And then the LED will light up when you go, and I thought that was a kind of a fun function that I found in the NeoPixel library, so I just decided to implement it. And for my challenges, the first one, the main ones I had were with my flex sensor. It kept bugging and it angered me a lot. The first one was after I velcroed on my flex sensor, my flex values were going up all the way to 4095, which means that there was a short happening. And I found out that when I soldered on my 2 jumper bars, one of the strands of the copper wire was touching the metal pin on the back of the flex sensor, and that was what was causing the short. So after I removed that, it started updating normally. And the second challenge was after I had sewed everything and soldered everything onto my PCB board. I thought everything was going to work fine, but then my LED light and my flex sensor, they both completely shut down and stopped working. And the reason was that the 2 power and the ground lines on the sides of the PCB board, they aren't connected by default, so I had to connect them using 2 small connecting wires. I don't know if you can really see, but it's like these like 2 like small red white wires there. So after I did that, my LED turned on and my flex sensor started updating again. And the last challenge I had was even after I completely finished my project, my flex sensor was still giving me really fluctuating values every time I tested it, and the function that I used, the map function that converts resistance to angles, it kept giving me like 200-degree angles and 500-degree angles, which was completely wrong. So I decided to let the user actually calibrate it themselves. When they first start running the code, they have to hold out their wrist at 0 degrees, and then it will get the average of those resistance values. I made a for loop that would run 50 times, and then do the same for when you tilt your wrist to 40 degrees, and it will get the average for when you tilt it at 40 degrees, and it will use those 2 averages as the parameters of your map function. If I had more time, I would probably improve the precision of my accelerometer, because right now when monitoring wrist turns, it's only monitoring when you go down and up, and it's only giving you 2 seconds to do that. But I want to monitor when you go in all 4 directions, so let's say down, right, And I would probably also do some cable management because this looks really bad right now. And if you were to go on public, you'd probably break it or something. So I'd probably add some tape and get the wires all organized. And at my time at Bluestamp, I definitely learned a lot. First one was I learned how to code in C++. I learned what libraries were and the methods. Specifically, I learned what a macro filter is because it helps convert the values of my accelerometer into orientation along roll, pitch, and yaw, which is the axes that planes rotate about. And I also learned how to solder, which was really fun, but I think someone had a similar experience, but I burned my ring finger, and that kind of hurt. And then I also learned how to sew, and sewing is actually a really useful skill even outside of engineering. But I ended up poking myself a few times also, so that was fun. And I think most of all, I learned how to troubleshoot, and my instructor taught me how to be patient and try different things when something isn't working. So yeah, thank you for listening. So if anyone has any questions,
What's your favorite part of working on your project?
the LED ring because it can turn rainbow, and I can like tell each of like the different like lights what to do. It's pretty cool.
Think your project is like ready to use like when people injured their wrist from table tennis, or you think you need some like more work before it can get there?
I think, but like you have to be kind of a daredevil to use this when you're injured because it might break your wrist even more. I heard my wrist crack when I was demoing it. So,
Is there any place that you plan on securing the battery pack?
well, maybe I could like attach like fabric on this side and then maybe like sew, well not sew, but like I don't know, like glue this on. But right now I'm just assuming the user has pockets, so like you can like slide it in your pocket.
So like say it became like a more production ready like model, like what's the feasibility of using it during practice? Like does it
During practice?
Yes.
No.
Okay.